Welcome guys, so keep solving our physics subject GRE and be sure to subscribe to my channel. Okay, so 71, basically you have a particle and there's an electric field. Then it start to increase. I start to their y increase and x also, x is the velocity v. So basically in x directions you have just vt. And the t is just d over v, right? Okay, so this is x directions, x equation motion. This is the final t, and the y is just the uniform acceleration square, and a is just ma, a is just f divided by m, and f just qe divided by m, which is q voltage over md. Okay, so y is 2 qvmd t square. Okay, so dy over dx, which is the tangent theta, which is dy over dt, dx over dt, which is v, and dy over dt. Oh, okay. Shit. I mean, I use large V for the voltage. I try to okay make sure that this large V is not confused about this small v. Okay, so I may pronounce nu, but you know that nu is the velocity here. So it's at. Okay, so tangent theta just a t divided by nu. Okay, so plug all the quantity we have, which is t, we have d over nu. So the answer is a d over nu square. A is this, so we have q v d m d nu square. So theta is just arctangent q v d m d nu square. Okay, yes. It's nice that we solve this question. Okay, so which one is the answer? Basically you just need to look it carefully because you already solved it. So you just need to read carefully and you get an answer. So the answer is A. The answer is A. Okay, 72. Which of the following is usually introduce the negative feedback? Negative feedback. So the answer is A, right? Negative feedback. So usually you because it's negative feedback, so usually it's not it will not increase your amplification. So 73, a diabatic equation which is defined by the PV gamma. So it's very nice that somebody gave you the answer. In other GRE exam, in other GRE exam PV gamma for a diabatic equation. This term at least you need to remember. And then ask about the work, right? Work is what? PdV, right? So P is just C over V gamma, C over V gamma dV. And then we from V1 to V2. Then this is the answer. So, okay, so it's C dV over V gamma, V1 and V2. So we do the integration. Okay, so what we have is minus gamma 1c over v gamma 1 v1 v2. So plugging and it changes something into p. What we get is pf vf pi vi 1 minus gamma or v1, or I use 1, but in the you just use I. So this is the answer. This is it. At least when you do the integration, you say there's you can see there's a 1 minus gamma, right? So C is the only answer. C is the only answer. Okay, so 74. Basically the body has the mass with specific heat and temperature both correct into the identical body 100K, and the 2 are isolated from surroundings. So change of the entropy of the system. So entropy just dq over dt. So dq, which is mc delta t. So you go from 100 to you go from okay. So you go from what? You're from 100, and t1 is 500, and t2 is 100. Okay, and so basically you boil into two of the context, so the result will be 300. 100 plus 500 is divided by 2 because they are identical objects. So you're from 100 to 300, and then you also from 500 to 300, and the MC dt t. So this is the total, the first one plus the second one. So basically you have MC log t. 300, 100 plus log t, 300, 500. So we have MC, this is log 3 plus log 3 over 5. Basically is 2 MC log 3 minus MC log 5. Okay, this is 3 over 5. Yes, so this is the answer. This is the answer. Okay, so which one is the answer? 2 MC log 3 is MC log 9. So the answer is B. The answer is B. Okay, so enough for today, and I will see you guys for the next video.